welcome back to my class. In the series of learning data structures through C, in today's video, we will be learning about how to create a node. So we have learned what is linked list, what is dynamic memory allocation, Kellogg-Malloc functions, and how the pointer is helping for the linked list. So how to create a node. So we have seen the list of operations, creating the node, traversal, insertion, deletion. So we need to see all those operations one by one. So before that, we have to learn how to create a node. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Node creation code. So this is what the node creation code. How to create a node. So as we all know, the node contains two parts. One is the data part, the other one is the link part. So how to create this structure means obviously we have to go with user defined structure. So in the user defined structure, we will see how to create this node structure. Means a node has to be designed in such a way that it contains a data part and a link part. Link means address to the next node. And this structure is not a simple structure. It is called as self-referential structure. It is called as self-referential structure. So what is this self-referential structure? The name itself tells you. It is going to refer to itself. Self-referential structure is a special structure which will refer to itself, means once again it will point to the same structure and the same structure is created again. And those structures are pointed to by pointers. So a new memory will be allocated dynamically, and to allocate that memory we use the dynamic memory allocation, the Kellogg and Malloc function, or Kellogg or Malloc, any one function. And using that Kellogg and Malloc function, we allocate the memory dynamically and we make the pointer to point to that memory, means that pointer should also be of the structure type itself. So first of all, we should know how to create that node structure. Node creation code. This is what the code we need to follow for linked list operation. So we need to create a structure. So I can give the structure name as node itself. So the name of the structure, the new user defined data type that what I am creating is node. Followed with two members. One is of integer type and the member name is data. The other one, look at here. It is a special member where it is a member of the same user defined structure type itself. So it is struct node itself, but not a normal variable. It is a pointer variable acting as member. A pointer variable acting as member of the structure. Member of the structure. Which structure? Member of the structure, the new data type that what I have created, that is node. So I say struct node, the structure name is node. If you have any doubts with structure, please do refer to the playlist of C language. You will know how to create a structure. Structure is a user defined data type. See, the normal fundamental data type can hold specific type of data. Integer can hold integer data, float can hold float type of data, like that. But if I want to have a structure type, so here I need to create a structure type of data. A structure type of data means I have to design that data type. The user has to design the data type in such a way that it can hold a variety of data. A structure is a heterogeneous type of data structure which can hold variety of data. And that variety of data I need to define here in the structure definition part. So it is integer, data, struct, node, pointer variable. This is self-referential structure because here I am creating a pointer variable of the same user defined data type, means this structure is once again pointing to the same structure. Means refer to the same data type and create a pointer variable of this type itself. This is of fundamental type, but this is of user defined type. This is fundamental data type, basic data type, int. But struct node is user created data type. So I am creating a variable, not a normal variable, pointer variable that is referring to the same structure, means it is a variable of the same structure type itself. User defined type, node type itself. So using this structure, I create this node format. So this is what the node that we have created, which contains data part and link part. Whereas it is a link, it's a pointer, it has to point to one more structure, but that one more structure is of the same structure node type. That is what? Self-referential structure. So it is a pointer, means it has to point to one more location. Where I can store node type of data, means once again data and link. Again it's a pointer variable, it will point to one more location where I can store again the node type of data, means data and link. So hope you have understood with this. So this is what with the node creation code, and then later we have to use that node type and we have to allocate the memory. So what I'll do every time when I want to use the structure type of variable, so you all, this is structure definition and this is structure declaration. Variable structure definition defines the members and structure declaration defines the variable. So here what I'll do, I'll type def this. Type def means type definition. Every time it's quite difficult to use complete word struct node, struct node. So I type def this complete struct node to a new name, that is node. Means I'm giving a new name. So I can, in future, I can use this particular data type name. Like how I use int, I can use node. So I'm redefining the name of this user defined data type from struct node to node. So that every time when I create a variable of this structure type, I can simply say node. So I'll use this node, I create a pointer variable. I create a pointer variable. So a pointer variable is ready to point to a memory block allocated by malloc function that can store node type of data. So I just say node asterisk ptr pointer variable. So a pointer variable will be created, and to this pointer variable I should get a memory block. So to get that memory block, I write a code node asterisk. So in the previous video we discussed about the dynamic memory allocation, how to use malloc function. So I use malloc size of not normal data type, this fundamental data type we saw in the previous video. I say size of int, but now I should say size of this user defined data type node. So I allocate a memory of this node type. Node type of memory means to store data and a link. Link is address to next memory. And typecast that to node type means here I say with the help of malloc function allocate a memory of node type, and typecast that to node type means node asterisk means you typecast that to node pointer, store that address into this pointer. So PTR points to a location. Just assume I have got a free location in 100. So that memory block will be held in PTR. So now PTR is pointing to 100. So in this memory, I can store data and link. Once again, I create this, add this line to allocate next memory. I say PTR equal to node asterisk malloc size of node. Once again, a new memory will be created. Then say the new memory is 200. The link, which is a pointer variable of the same. So link is a pointer. It has to point to a memory block that can store node type of data. Node type of data means once again data and link. Once again data and link. Two members. So here the address is 200. I say 200. It is pointing to 200. So here I just fill some value. I just say 70. Again a link pointing to a new location. So the new location is 300. So it is pointing to this location. Say data, I'll just say 77. And link, I just say I don't want to point to any more locations. I say null. End of the list. So this is how we go on creating the linked list. So hope you have understood with this self-referential structure. If you have any doubts with structure itself, you can just ask your doubts in the comment box, and please refer to the playlist of C language so that you can get cleared with the concept of structure. So that's all for today's video. So in the next video, till then, take care. Bye bye.